Welcome to True Projects. In this video, we are going to explain about the project that is Verifiable Encrypted Image Retrieval with Reversible Data Hiding in Cloud Environment. So before getting into the execution, first let us understand what is this project about. These days, we are creating and sharing images at an incredible rate through social media, healthcare systems, and security cameras, for example. So, because of this, people and organizations often store their images on cloud servers, which are convenient and they can handle huge amount of data. But using the cloud also brings risks. Sensitive images like personal photos or media records could be accessed, misused, or analyzed by cloud providers without permission. So, to keep images safe, they are usually encrypted before uploading. Encryption protects the content, but it also makes searching for images harder. Normally, image search methods rely on features you can see in the image like colors, shapes, and textures. Once the image is encrypted, these features aren't visible anymore. So, traditional search methods stop working. This means we need ways to search for images securely in the cloud without exposing them. And even though there are systems designed to search encrypted images while keeping them private, they still have some big problems. Many of these systems rely on simple or manually chosen image features, which means they struggle to accurately find similar images, especially when the images are complicated. On top of that, the way they organize and search through the data isn't very efficient, so it can take a long time to get results. So, from security perspective, some systems leak a part of the image features or don't check whether the search results are genuine or not. This opens the door for the cloud server to potentially manipulate or tamper with the results. So the main challenge here is to how to create a system that can search images accurately and also quickly, keeping the images safer and their features private, and also make sure that the results returned are trustworthy and haven't been altered. And here, to overcome from all such issues, the proposed system is designed to let users safely store encrypted images in the cloud while still being able to search for similar images and trust the results. It uses a deep learning model called VGG16, which has been slightly modified to extract meaningful features from the each image. These features are then turned into a series of binary bits which are organized into a special index called addition homomorphic bitmap, that is AHB. By encrypting this index using homomorphic encryption, the cloud can perform searches and compare images without ever seeing the actual features, keeping the content completely private. And here, to make sure that the search results are correct and haven't been tampered with, the system also generates a unique authentication code for each image. This code is hidden directly inside the encrypted image using a technique called reversible data hiding, that is RDH, which places the code in the least significant bits of the image. This way, the verification information stays secure and doesn't require extra storage, while still allowing users to check that the results they give, that is, they receive from the cloud, are genuine. And this proposed system performs computation from scratch for every user, that is, every query, which can lead to repeated processing and high computational costs when the same query is executed multiple times. So, to overcome with this project introduces an extension that is designed to enhance efficiency and reduce computation time. So, a cache memory is integrated with the executing server to store the results of the previously processed queries. Whenever a user query is executed and results are obtained from the cloud, both the query image and its corresponding results are saved in the cache for future reference. When a user submits a query, the system first checks the cache memory to see if the same query has already been processed. If a match is found, the stored results are directly retrieved and returned to the user without re-performing the computation. This approach saves the significant processing time, reduces the cloud storage, that is cloud reuse usage, and improves the overall response efficiency of the system. And here, this project is implemented through all these 6 modules. So first, new user sign up. This module allows new users to register with the system. So users provide basic information like username, password, email, and contact details. Registration ensures that every user has a secure account to access the platform and manage their images. Then the next module is the user login module. After signing up, users can log in using their credentials. So the login process verifies their identity, ensuring only authorized users can access the system and perform image outsourcing or searches. Then comes training and loading VGG16. So the system uses a pre-trained VGG16 deep learning model to extract image features. This module either trains the model on datasets like Flickr or the loads pre-trained model. So here in the background part, we are training the VGG16 with the Flickr, and in the pre-trained, that is in the front end part, we will be loading the pre-trained model. So the extracted features are used to secure content-based image retrieval. Then comes outsourcing encrypted image. So users can upload their images to the cloud in an encrypted format. During this process, image features are extracted using VGG16 and an authentication code is generated and embedded using reversible data hiding, that is RDH. The encrypted image along with its features and verification code is then securely sent to the cloud for storage. Coming to the next module, that is search verifiable image. So when a user submits a query image, the system extracts its features using VGG16 model and performs a search on the encrypted feature index in the cloud. The results, that is the returned images, are verified against the embedded authentication code to ensure that results are genuine and have not been tampered with. Then the last module is the computation graph. This module tracks and visualizes computation time for different search methods. This includes standard CVR encrypted feature search and cache-based extensions. It helps to analyze efficiency, improvements, and compare performance between methods. Moving on to the requirements to implement this project, basically we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, open the code folder that contains source code files. So these are the source code files of this project. Let's understand each of them. In this folder, we have the Flickr dataset. So here we have multiple images. So here we have images of the beaches. So when we give an image related to beach, so the model will be extracting, model will be giving relatable images of these beaches. And here we have images of the bus. And here we have images of dinosaurs. And here we have of elephants. So these are of elephants. Similarly, we have for all other classes, that is flowers, foods, horses, monuments, mountains, and people and villages in Africa. So we will be using VGG16 model to train features of all these images. Now let's get back. And this is the model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And here in this folder, we have the images that we will be using in the front end for uploading the images. And here we have static folder in which we have files related to CSS, JavaScript, and Bootstrap, which are important for the project visual appeal. And here we have templates folder. So in this folder, we have HTML pages that are used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have image encrypting Python file. Here we have manage.py file, and here we have sc.py file. And this is the database file which is used to store the user information. And here we have Windows batch file. So instead of executing this project through command line interface, we have created this Windows batch file. So we need to double click on it. So click on it, click on run. So here if you observe, app file has been compiled. So now application will be running the Python script and check for any syntax errors or logical issues. And after running this file, application will host the, that is Flash framework will host the application at the default address, which is the local host and the port unless configured differently. So just wait for a while. So this is the address where application has been hosted. So copy the local link provided by the Flash framework and paste it into any web browser. I have copied it and I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flash framework. So we need to get registered. So click on new user, sign up your link. and enter all the registration details if you haven't registered, and you need to fill in all these details. I have already created account, so I will directly sign in. Click on sign in. So provide your username and the password to log in, and now click on login. So if you observe, we are redirected successfully to this prediction page, that is to the home page of this project. And here first we need to click on train and load VGG16 model. So click on it. So here you can see the model performance. The model has been loaded and it is trained. So this is the ResNet 50 accuracy score, and this is the precision accuracy score. I mean ResNet model's precision score. This is the recall score, and this is the FN score of this ResNet model. And this is the proposed model's accuracy, which is 98%. Precision is 99%, recall is 98%, and FN score is 98%. And these are the four metrics that are used to evaluate this. So now click on outsource encrypted image. And here you can see a choose file option, right? Here we need to click on it for uploading the image and encrypt it. So let's click on choose image file. So here from these images, you can select any image, or you can even select from this folder also. So let's upload images from this, or else let's get back. Let's open Flickr and let's try with the horses. So select this image, click on open. So this image will be encrypting now. So click on encrypt and upload image. So it's being encrypted. Just wait for a while. And here you can see image has been successfully encrypted and also uploaded. So this is the verification code for the uploaded image. And here we have current user. So we are the user. So that is why it is showing current users. And this is the date when that file has been uploaded. And here you can see file is the uploaded image. Now let's try with the other image. So click on close. So now let's try to upload the other image. Click on choose file. Now let's try with the other image. So let's try with this folder. So let's select this image, click on upload it. And here you can see image has been successfully encrypted and it is also uploaded. And here you can see this is the verification code. And here we have the current user, date and uploaded image. Now close it. So this is the encrypted image outsourced to the cloud. Verification code is this one. So now let's search for the verifiable image. So click on search verifiable image. Now click on choose query image. So let's get back and upload from the query images. So let's try with this image, that is the elephant one. Click on open and now click on search similar images which are similar to this elephant image. So now application will be showing the similar images. It will be generating the similar images. So here, this is the original image we have uploaded, and here are the original, here is the retrieved three images, which is similar to this image. So these are the other two similar images. And here, if you see, here we have three more original images. These are the three more similar images. And here we have six more original images. So let's close this. Let's search for the other images. Let's query the other images. Close it. Now click on choose query image. So let's search for this one. Click on search similar results. And here images are generated. So this is the original one we have given. And here is the three images that are retrieved, which are similar to this. So you can see it is similar to beaches. So that is why it is showing three images. So here we have four more images. These are the three more images. And here we have other four images, which are similar to the original image that we have uploaded. This is the image, right? So these are the four more similar images. In this way, you can search for any number of images. So close it. So you can just query the image and you can click on search similar images. So based on the given query image, you will be getting the results of these similar images. So now let's check with the computation graph. Click on computation graph. And here we have image-based query time graph, where on x-axis we have technique name. So here on x-axis we have technique name and on y-axis we have search computation time. So the green color is the extension cache, blue color is the KNN based search, and the orange color is the proposed search. And here we have KNN based search performance, proposed models search, it is excellent, and extension cache search, it is outstanding. So now click on logout. So in this way, this project, it lets users safely store and search their images on the cloud without worrying about privacy or tampering. The system ensures that even though the images are stored remotely, only the rightful owner can verify and access them. So we also made it faster and more efficient by remembering the previous searches so the repeated requests don't waste time. Overall, this project provides a secure, reliable, and user-friendly way to manage and search the images in the cloud. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.